complex fractions are just fractions within fractions with variables. And then we're also going to rationalize the denominator today. So what you want to do when we have complex fractions is really just look at each denominator, all right? So these have the same denominator. You can actually copy dot flip like old school, but I'm going to teach you an easier way that's going to work every time, that's going to make your life better, all right? So if you have both divided by p, we're going to always pick the common denominator, and we're going to cancel that fraction. So what I'm actually going to multiply by is p over 1 over p over 1. So what I'm really multiplying by is p over p, which is allowed, okay? It's 1. So I'm really multiplying this whole fraction by 1. You can always multiply something by 1, and it is still equal to itself. So what happens here is that these p's cancel, and I'm left with m over 1, which is really just m. Okay. And same thing in the denominator here. The p's cancel, and we're left with z plus x over 1, which is really just z plus x. And that's all you have to do. Sam? Yes, but eventually you cannot do it this way, so you could do it like this, right? Where you take this whole denominator, and you flip it, and you get that. But there's going to be harder ones that you can't do that on, so I'm teaching you the easy way first. Because this is another one that you could definitely do that on. It'd be super easy. But if you keep it consistent, promise you it'll work out better this way. So look at what's in the denominator, and we're going to multiply by the common denominator. So both of these denominators have x plus y. So we're going to multiply the top by x plus y over 1, and the bottom by x plus y over 1. So whatever the common denominator is, we're going to multiply top and bottom. Because I'm really multiplying the whole entire fraction by 1, it's allowed. We're not changing the value. So what happens here? X plus y cancels with x plus y, and I'm left with m over 1, which is really just m. And in the bottom, x plus y cancels with x plus y. I'm left with z over 1, which is really just z. That was pretty easy, just like the last one. All right. I guess this all starts off easy ones. That's all we have today. All right. So rationalizing the denominator. 4 over 3 root 2. Okay, you cannot keep radicals in the denominator. We always want to do what's called rationalizing the denominator. We want to get rid of any radical or square root that's in the denominator. So the only way to get rid of a square root is to multiply by itself, so we can have perfect square roots. So what I'm going to multiply by is the square root of 2 over the square root of 2. So I'm multiplying the radical by itself so that I get a perfect square number, and it'll get rid of the root in the denominator. So in the numerator, I've got 4 root 2. And in the denominator, the 3 is multiplying times really a 1 right here. So that's just a 3. And 2 times 2 is 4. You can skip that step if you want, right? Because what's the square root of 4? 2. So now I have 4 root 2 over, this is just 2. 3 times 2 is 6. Okay, always look to simplify radicals and fractions, right? The only numbers that can simplify here are the outside numbers. So since 4 and 6 are both on the outside of the radical, those reduce to 2/3. And the root 2 stays. So that's how we get rid of the radical in the denominator. Also, what number is this that I'm really multiplying this by? 1. So I'm not changing the value of the fraction, which is important. All right? Another really easy one. So 1 over the square root of 2. You see this one in trig a lot. So we have to rationalize the denominator here. We're going to multiply by the square root of 2 over the square root of 2. So in the top, 1 times the square root of 2, you can just put square root of 2, or you can put 1 root 2, same thing. And again, if you want to do this in your head, the square root of 2 times square root of 2 is square root of 4, which is 2. Okay? And we got rid of the radical in the denominator. And they are equal values, all right? Because we really just multiplied by 1. That was a really short lesson today.